Welcome to our channel. Today, we discuss one of the most tantalizing, mind-bending questions in all of science and fiction. Is time travel possible? From H.G. Wells' The Time Machine to Back to the Future, the idea of zipping through the centuries has captivated our imaginations. But here's the twist. Despite decades of blockbuster movies and wild theories, most scientists argue time travel is impossible. Or is it? Buckle up, because we're about to dive into the physics, paradoxes, and tantalizing loopholes that keep this debate alive. Let's start with the basics. Time travel isn't just about building a DeLorean with a flux capacitor. It's rooted in real science, specifically Einstein's theory of relativity. Einstein showed that time isn't rigid. It's flexible, like a fabric that can stretch and warp. The faster you move, the slower time passes for you relative to someone standing still. This is called time dilation, and astronauts on the International Space Station experience it. After 6 months in orbit, they're technically a fraction of a second younger than the rest of us. So, in a way, they've time traveled forward by a blink. But what about going backward? That's where things get tricky. Einstein's equations allow for hypothetical pathways called closed time-like curves, loops in spacetime that could, in theory, let you revisit the past. The catch? You'd need exotic materials like negative energy to stabilize these loops, and we've yet to find any. Even if we did, the energy required would dwarf anything humanity could produce. It's like trying to power a time machine with a AAA battery. Then, there's the infamous grandfather paradox. Imagine traveling back in time and accidentally preventing your grandparents from meeting. If you're never born, how could you exist to time travel in the first place? This logical nightmare suggests the universe might have a built-in, no backtalk, rule to prevent contradictions. Some physicists argue the universe would self-correct. Maybe you'd slip on a banana peel before touching the past, or a quantum glitch would reroute your plans. Others say the paradox itself proves time travel can't exist. After all, if it were possible, where are all the time tourists? The Fermi paradox of time travel. If future humans crack the code, why haven't they visited us? Maybe they're discreet. Maybe time travel only works forward, not backward. Or maybe, as Stephen Hawking quipped, time travel is impossible, and that's why we're not drowning in historians from the future. But let's not give up yet. Quantum mechanics, the Wild West of physics, offers a glimmer of hope. Particles like electrons don't play by classical rules. They can exist in multiple states at once, superposition, or teleport information instantaneously, quantum entanglement. In 2020, scientists simulated time travel by sending a qubit, a quantum bit, into a state that mimicked its past. It's not Marty McFly stuff, but it hints that the quantum realm might bend time in ways we don't fully grasp. Another avenue? Wormholes. These cosmic shortcuts, predicted by Einstein's equations, could connect distant points in spacetime. To turn a wormhole into a time machine, you'd need to move one end at near light speed. Time would slow for that end, creating a bridge between, say, 2023 and 3023. But wormholes are theoretical, and keeping one open would require exotic matter with negative mass, something we've never observed. Even if we cracked the physics, the ethics would be a minefield. What if a time traveler accidentally wiped out humanity by stepping on a butterfly? Shout out to Ray Bradbury's A Sound of Thunder. Or intentionally altered history for power? Governments might ban time travel outright, or fight wars to control it. So why do scientists keep chasing this? Because time travel forces us to rethink reality. Studying it has led to breakthroughs like GPS satellites, which account for time dilation, and quantum computing. The idea of time travel pushes science forward, even if the real thing stays out of reach. But here's the kicker. Some physicists argue time itself might be an illusion. Our brains perceive time as linear, past, present, future, but in relativity, time is a dimension like space. What if all moments exist at once, and time travel is just moving through a static block of spacetime? In that case, free will is a myth, and your future is already written. Depressing? Maybe, but it solves those pesky paradoxes. Let's get practical. Suppose time travel is possible. How would we even test it? One group of researchers proposed sending photons into a simulated time loop using mirrors and lasers. Others looked for ripples and cosmic radiation that might hint at visitors from the future. So far, no luck. But the search itself is a testament to human curiosity. In the end, the answer might depend on what kind of time travel we're talking about. Jumping forward? Relativity says yes. Just hop on a spaceship near light speed. Jumping back? The universe seems to have a firewall against it. For now, time travel remains firmly in the realm of fiction. Or does it? If you're equal parts disappointed and intrigued, you're not alone. The line between impossible and not yet possible is razor thin. A century ago, airplanes and the internet seemed like magic. Who's to say what's next? If you enjoyed this journey through space-time, hit that like button, subscribe, and let us know in the comments. If you could time travel, where or when would you go? Thanks for watching, and remember, even if we can't revisit the past, we're all time travelers, marching into the future at 1 second per second.